All right, welcome. Week 5. The schedule is available. You can't register yet, but the schedule of classes is available. So if you go to the website under registration and financial aid, schedule of classes, you will have to click it from fall to winter. I already did that. But it'll default to fall, the current one, and then you won't notice that, and you'll go in and go, oh, all these classes are different. So switch it to winter, switch it to engineering, and go search, and you'll see the courses that are offered in the winter. Okay. If you are engineering transfer, you're looking at the courses that have a ENGR in front of them, or potentially a GE in front of them. This is GE101. Obviously, you're already in that. Guess if you don't pass it, you could take GE101 in the winter. But this is where you're going to find the classes that are available for the winter. The engineering classes. You'll have to go, switch it to math to see math, switch it to writing to see writing. The ET courses are the courses offered for the engineering technology program. The ET courses are available to everyone. Anyone. If you're an engineering transfer student and you see an ET course that looks interesting, you can take it. You just have to meet a prereq, which you probably do if your math is above 111, 95% of them 111. So you can look through those. It looks like I'm pretty much teaching everything next winter, so you'll have me, I think, for something. That's not true. I'm not teaching fundamentals. We do have an instructor for that, so that's good news. I am not teaching this strengths. Mines is teaching it. I am teaching the SolidWorks course. I am teaching advanced graphics, which is AutoCAD 2. So if you had GE115, AutoCAD 1, this term you can take advanced AutoCAD in the second term. It was like 2 years ago, there was a number of students who said, how come there's an advanced SolidWorks, but how come there isn't an advanced AutoCAD? So I can do that because I am the advisor for the 2-year program. And the 2-year program, I can do anything I want. So that's why it looks so different from the transfer program. Transfer program is controlled by university, university, and they're controlled by ABET, which is the accreditation body for engineering education in the United States. So the universities have to follow ABET, and the community colleges have to follow the universities for transfer. We can't muck around with it at all. But the 2-year degree, I sit down with employers and they say, hey, your students need to have an advanced AutoCAD. Okay. So it's a much more flexible education. But that's why the difference in numbering. That's why all the numbers cannot be the same. So you'll see that there's a ET 221 statics here, and then for the transfer students, there's a ENGR 211 statics, right? Different numbering, same course, engineering transfers, calculus based, engineering technology, trigonometry. Yeah, good. Calculus-based statics and trigonometry-based statics pretty much backwards. There's a couple opportunities to do calculus if you want to, and the instructor will show you that opportunity, but probably make do it because you do not follow statics. So there's some shenanigans going on there, and that's again controlled by the universities. The universities say it's got to be calculated. So that means calculus-based static has to choose a book that is calculus-based. They cannot choose the trigonometry-based status, like the one I use. Then I have students that scope that. I have students that take my statics and then some 21 tests and then they calculate space status. And it's the same thing. So they're like, you know. There are differences. The dynamics analysis is very calculate space. Right. Strength of materials. There's opportunity again to do it, but not much. But that's kind of the game. All right. So this is available if you want. I have your form. You knew that.
Okay, yeah.
I was glitchy. But I filled it out.
Thank you.
You just
Appreciate it.
Okay. I think it's more than people can see their bullets.
Thank you.
We want you to submit it and then we want them to try and turn it down and then we want me involved. Yeah. So, all right, good times. So some of you are already looking at schedule and that's a wise thing to do. You can't register yet. I did find that somewhere. Did anyone know where the registration calendar is? Oh, here it is. So I just hit the home button and there's the registration calendar. So registration happens on a credit level. So here's a winter term. I guess I could have scrolled down to it too, but whatever. Right? So it says schedule classes goes online October 19th. That's why it's available. If you have 75 or more, you can register on November 2nd. So the more credits you have, the more kind of seniority you get in register. That makes sense? And those are really for the general records. You're not going to get turned away from engineering course. Something like solid, which you could get turned away from, like potentially that will fill because everybody wants to take it, number one, and all the engineering students take it, both technology and transfer, and then, you know, random. Those can fill. That would be one reason to go in early on your registration time and actually register. But really, it's your math classes that everyone's battling for, but not typically disapproved because you're higher level math. And pretty soon, it's just you in those pathways. Those upper level calculus really rely on engineering. They're not going to take it unless you're not. There are a few math majors that will be in there, but not many. Good. 60 or more on the 3rd, 45 or more on the 6th, 37th, 15th, 8th. New and transfer students on the 9th. So it's really like to the day, right? That you can get in. So if you want in on your day, that's the schedule. Good. All right. If you don't know what to take, we did an academic plan. Hopefully that has somewhat helped, but we all know, the college knows, instructors know that, you know, that's subject to change based on, why doesn't it look like home? Yeah, interesting. Oh, it's because it's my MHCC. Let's go to Mount Hood. See if this works. Nope. How do you get back out? All the way out. Nope. Public home. Sure, get started. Oh boy. I want the homepage. All right. You've seen this a bunch, but one more time, programs and majors. Down to engineering. So in the schedule, you're just going to choose engineering and everything's going to show up, right? But if you go to programs, they're split there. Engineering technology, engineering transfer. So that's a little confusing. We've tried to get them to fix that and they won't on the schedule side. So let's say, okay, transfer is what I want. This is what I was supposed to be taking this term, GE101. So you did good getting in that. And then second term, this is what I'm supposed to take. So transfer students looks like they're in chemistry, hopefully chemistry 2. GE115, some of you maybe slid in this term. That's fine. You can take them in any order as long as there's not a prerequisite problem. Or SolidWorks, both of those are offered next term. And then your math, so. That's what a transfer student should be taking. First year. Good. I guess if you were rocked and rolled through those early prereqs, you could scroll down to the second year winter. Like if you had all your calculus done, you could slide into statics or strength of materials. Looks like strength of materials, right? But most folks don't have all that done for second year stuff. But if you are ahead and you're thinking, well, I could take something else, these are the second year winters that are also going to be offered. Okay. Any questions on any of that? All right. And then engineering technology. Here is the winter for those folks. So they're not supposed to be in GE1 right now. They're supposed to take it in the winter. Some slid in, that's fine. Doesn't matter. You can take those GE101s, you can take out of sequence, no problem. But come to the ET courses, 221, that should happen here because it's a prereq for 231. Statics is a prereq for strengths. They're also going to take advanced graphics if they've had GE115, which they should have. Or they could slide down and look at their second year winter where there's just a lot more job ready stuff that they could possibly use. When you're looking at these academic layouts, you can look at winter first and second and see if there's other courses. That's okay. Nothing wrong with that. As long as you meet the prerequisite, and if you like click on a class, sustainable engineering, it will tell you the prereq, right? It's reading 90, you all qualify, writing 90, you're all good, and math 20. Oof, that's a pretty low level math level. But when you're talking about sustainable engineering, you don't need to do a lot of math. Okay. All right, good. I don't know if that helps or you already knew all that or not, but now you do. Think about when to register and yeah, do that. Blackboard. This is where you keep track of stuff, so you should be checking it. It's 24th is today. What's the next thing that's due on the project? Anybody? Oh, that's pretty hard to see, isn't it? Code of ethics. Code of ethics, yeah, sorry. I guess that is pretty small. I don't know how to blow it up. I don't know that I can blow it up. Control plus? Jeez. Wow. You're right. So does control minus take it back? Oh, good.
Yeah, and then control equal.
No, I don't want any more. That's enough. The 30th is code of ethics. Yeah. So I guess emphasize, check this now and then to keep track of things. And I am going to try. I'm not trying to slide things by. I'm trying to do this. Like, hey, code of ethics is coming up on Monday. Have we had a lecture on that yet? No. So Thursday, we will talk about ethics in engineering. We'll the case study, talk about all of the different canons, they're called canons in engineering. And if you become an engineer, whether that's a 2-year or a 4-year, if you're involved in engineering, you're responsible for those code of ethics. Stuff goes downhill, and you all are going to be at the bottom of that downhill at the beginning. So when stuff goes bad up here, it's like it was you, pretty soon down before the person who made the drawing or something. You never saw. So you have to think about this kind of things. Also, what's happening on the 7th? I know you can't see it. Field trip. 7th and 9th is field trip. We're going to go to microchip. So you got to figure out how to get there. So here's the news flash for the folks that aren't here. You might share this with them. You have to provide your own transportation. I'm hoping teams work together in carpool. That's what I would hope. You can't come to me on the 7th and say I don't have a ride. Okay, don't do that. If you don't have a ride, maybe I'll ahead of time, and I'll try to get that coordinated. If during that, I know you're. I know things look sideways, and all of a sudden you get for some reason, you get people trying to decide. So I can't require it because it's not providing the information. It's easy points, like right? It's gonna be a tour of the facility, not the bath, so we shouldn't have to bunny suit up. I know some people really want to do that, but we don't do that typically. They talk about processes there, and they also talk about the facility itself, which is phenomenal. So if you're like civil engineering, when they talk about the facility and you go through the facilities, which is under the bath, it's incredible. Like, first of all, the building is incredible. It's on shopping center, essentially, to eliminate all vibration as much as possible. Because they make really good tiny stuff. So if you're trying to make really tiny circuits, and your platform is vibrating because the truck goes by, that's a big problem. So I'm not going to take it more away from the tour, but it's kind of a different tour than that. Hopefully, it's a different tour than average public tour. The other thing is, it's supposed to be given by engineers, Mercury Department, which means they'll be like, someone we're going to talk to something more, but at least they're going to answer a question. If you have a question about what is happening here, don't ask me, because I've been through this tour enough to know the equipment is freezing. Right? It's crazy what the equipment does as far as at the chemical level and what's happening. So I can never explain the data. So it's kind of cool to be able to ask a question. Anyway, that's our first field trip. Just a heads up, start to organize. It's right down Stark. I don't know if you know where Microchip is, but it's not far. It's too far to walk, I would say. Oh, maybe you could bike it. I don't know, but it's not too far. Yeah. It's next binder trip today. I know this is so like, so that means there's also one on Thursday. Today and Thursday, binder trip. How random? It is. So much random. I guess it's random, like right now. I'm telling you, it's kind of random. Thursday gets a little more heads up than Tuesday, right? That happens. That happens. They'll just get higher grades than everyone else. It's just the way it is. All right, good. Any other questions about anything? I think that's good for Blackboard. Good. All right. Let's talk about the team reports. I've gone through a lot of them. Not all of them, but most of them. The team formation paper, I think there's a few teams that didn't submit. Remember, that was a single submission for the team. Don't be hard on your teammate that you like put the crap on to submit and they forgot. It's their fault, yeah, but at least they said they would do it, at least they do it, right? And then you must not have confirmed that it got done because it didn't get done. All right. So if you didn't submit, that was a 50-pointer and you got a 0 on it. That's not cool at all. So here's how you get your 50 points back if you got a 0. You submit the report, not your team. Everybody submit if you got a 0 and you want your points. Right? So the first go around, if your team submitted, everyone was happy. Now that there's a couple that forgot or just didn't or had technical issues or whatever, there was some zeros given out. You can submit for yourself and get those points. But now it's week 5. So beyond week 5, well, that's not going to work. So if somebody doesn't submit the code of ethics, that's a 0. On 1. Okay. All right. Good. Everyone knows how to get their 50 points back? Okay. They were good, by the way. You all should look at them. It's interesting because we're all the same kind of thing, right? We're in the same engineering thing. Some were definitely more engineerish than others. And I am promoting you start to practice engineering. Start to practice being an engineer by everything you submit. and the actions that you do. Like, I'm still practicing at being a teacher, right? So we're all practicing at being ourselves, but you've chosen engineering to start practicing that. So you should look through them. There's some that dialed in, like, I would share that with other engineers. And there's others like out there that are like, not quite there yet. I would share that. Okay. I'm not opposed to handwritten stuff. You just gotta go kind of next level with the handwritten. And there was one report in there that was handwritten that was, I would share it with you. It was so pretty. Like the handwriting was gorgeous. That's not my handwriting. I would never handwrite a report and submit it to anyone. Mine's terrible, you probably already seen it when I do it with books. Right? So I didn't know, share that with people. But you can handwrite it. I'm okay with that. They were good. Let's get single documents in the future. Some of you went like off the rails with the single attachments. Like, see how many attachments we can get in this one paper. Like, here's the picture, here's the graphic, here's the picture of the graphic, here's, someone just kept going. So try to get it in one document. That can be a Word doc, that can be a PDF. I don't care what it is. Just get it into one. Right? I mean, Word's pretty easy. You can drag pictures in, you can drag graphics in when you say it is one file. Okay, so try to get them to one file. Full names on anything you submit to any instructor or other engineers. Full names, not just first names. There could be more than one David in the room. And we don't really want other people to have to figure that out, right? We want them to know who you are. So full names is good. If you print clean, raise your level, practice being an engineer. All right, good deal. I think I'm through. Oh, I haven't got completely through the problem definition stuff, but I'm getting there. So that means there's grades in there and you should be checking those grades. Okay. Remember this, I'm going to visit this often and encourage you to try and follow it, like, and document that you're following it. Okay. So we are in the early phases of identifying the problem statement, brainstorming, possible solutions. That's where we're at, is that generate ideas, research, and brainstorm. Then we were asked to choose some solution, not just one, but you have more than one solution. So you're working with it. Right? And then prototyping will be coming up. All right. The graphics were all over the place, which was fine, because I just said produce some graphics of the ping pong ball, right? We had a ping pong ball launcher. I do think I said engineering graphics, but they were all over the place, all kinds of. I got some computer generated graphics that were pretty cool. I got some hand graphics that were pretty nice. I got some sketches that were pretty bad. So I want to give you some just brief skill set in graphics. So if you have GE101 right now, this will be a little bit redundant. If you have these problem solving, this will be a little bit. But I want, in the future, I'm going to ask for graphics and I want them to be kind of conform to the engineering standards. Okay. Basic graphics are what we call orthographic projection. Ortho meaning 90 degrees. When we're looking at something from 90 degrees, we see just that flat surface. This is an orthographic projection of a part where I see the front view, the top view, and the right side. Super common. So if anyone said, hey, produce me some engineering graphics, this is where we start. With a basic front view, top view, and side view. The projection thing is, from the front view, everything projects to create the right side view. In other words, the bottom of the front view there is a super cool laser pointer earlier. I wanted to use it. You can see my mouse, right? Yeah, bottom of the front view lines up with the bottom of the right side view. Everyone see that? That's projection. It means that an edge projects to something in another view. The left side of the front view right here, I'm gonna blow it up. The left side projects up and is also that same side of the top view. Things project to other views. That's what orthographic projection is. Okay? And you take a three-dimensional object and you get these flat views. Basically. The other thing with engineering graphics is there's a title block. There's a border around the drawing with information. Basic information for this class. Most of the classes are basic information, maybe the name of the lab, maybe the name of the course, whoever drew it. So it should say drawn by Joseph, right? It's a fixture bracket. Seat, that used to be when we had like seats of drafters. You would be identified by your seat number, not so important. Sheet 2, or it could say sheet 2 of 2 or 1 of 2, right? Then I would know how many drawings in the drawing packet. So if you're going to submit like a 4 drawing set, it would be 1 of 4, 2 of 4, 3 of 4. So then whoever got it would know that there should be 4 drawings here and only 3 you're missing, right? Okay, and then a scale. So if it's a 1-to-1 drawing, it's real life size, then it's 1-to-1. If it's half as big as it would be in the real world, then it's 1-to-2, half scale. 1-to-3, third scale, 1-to-4, quarter scale, 1-to-5, fifth scale, right? Because you gotta get it on paper. All right. So a title block would be part of engineering graphics. Like, hey, produce an engineering graphic, I should think, oh, that's probably gonna be like a graphic projection. Should have a title block that kind of organizes things. A lot of times you'll see dimensions around the thing. I'm not probably gonna go into how to do that completely clean. But clean is what we're looking for, and full shape description would be what the dimension full, like full shape description. Full position of everything. So if there's a hole, is a position. Is there a shape? What size is that? That's your dimension in class, right? Sometimes in the title block, you'll see dimensions in millimeters, dimensions in inches. Then you don't have to label all that. All the numbers just be numbers. So that's a good thing to put in there also. If you're going to do a sketch, your engineering graphics is going to be by hand. That's fine. Just clean it up. Like literally just use a straight edge. And then the difference between engineer A and engineer B, it'll just look different. It may still be wrong, but it'll look. So just use a straight edge and clean it up if you're going to do it by hand. This is the little thing that kind of identifies this orthographic projection concept from a three-dimensional object, how we get the front view, the side view, and the top view, right? We put this glass box around it and just unfold it. Every visible edge creates a visible line. So if you can see it, it's going to create a solid, visible line. Like the entire front view is all solid. I can see all of this geometry when I look at this from the front view. Agreed? Everyone kind of see what I'm talking about there? Edges create lines in your drawing, right? If I look at the right side view, all of these continuous lines I can see from the right side. These hidden lines are geometries that I cannot see. What are those hidden lines for? The holes. Yeah, I can't, from the right side, I can't see the hole. So I put in a hidden line for the top and the bottom of that hole. And that helps the viewer, whoever's using this thing, helps them build this three-dimensional object from this two-dimensional drawing. It's super important. Same with the top view, we have some hidden lines in it. Yeah.
Like today when we were in the other class,
Yeah.
I saw several drawings, and actually did the hidden lines, but they didn't do the center line.
Yeah. So the center line is associated with dimension. So everyone know what a center line is? Yeah, center of the circle has two center lines. This thing, right? Yep. So that's actually called a center mark because it's the full cross. So it's doing a couple things. It's positioning the hole. So when I go to dimension it, I'll use the center line, right? If I was just doing the, orthographic projection, I wouldn't need those unless I planned on dimensioning, right? Notice that there are some longer ones, like these are long dashes, but then this one stops kind of short. So these three are associated with the outside arc. That's why they cross the outside arc. This little creature here is just associated with the inside hole. So it just stops past the inside hole. So we position everything, not just holes. But if there's an arc or a fill in the long, then that's what the center line is. So, was that your question?
Yeah, my question was, I saw about 3 drawings that they didn't have the center line.
Yeah, I said they were.
Oh,
If they're not dimensioned.
you had to mention it because we're dimensioning.
Yeah, if they're not dimensioned, then it's not that helpful, although it is helpful once you start reading drawings. This center line here, what's that one marking? The hole, right? Yeah, so once we know that, then that helps me with the two hidden ones that are also by that center mark. Oh, that's the hole. And it seems very obvious here, but when it is complicated, it is not like, hidden lines all over the place. Maybe like, what is it like, right? So sometimes a center mark or center line can help kind of associate with holes, because holes we're going to position for sure. We need to know exactly where they are, right? Good. So yeah, then it unfolds and you get your multiple views. Your primary views are front, right, and top. Front, right, and top. Other orthographic views are bottom and left. Those are all 90 degrees, right? Take an object and go 90, 90, 90, 90, right? All right, I'm gonna cruise through some of this. Dimensioning, I'm not gonna spend a lot of time on it. Just if you're gonna dimension something, which I will have you do graphics on your project, and you will have to dimension it. Just try to keep them clean off the object as much as possible. So notice how all that dimensioning all around the object, right? And that it's kind of clustered. So information that is important to make is used together, keep it together. Like the position of the hole. The X dimension and the Y dimension, the position of the hole are clustered down by the 22, you could have pulled it all the way up off the top. I mean, that's not illegal. You can pull it up there. It just wouldn't be anywhere near the 14. So it's going to be more of a struggle to find. So just cluster and keep it off the object. There's maybe 100 standards there that I'm not covering. So there you go. Yeah.
What software do you recommend? Like Fusion 360 or?
So I would recommend the two that we have on campus, which is SolidWorks and AutoCAD, because I know everybody has that. But I'm not requiring you to do it in computer. In this class, you don't have that skill set, so you can do it by hand when you do your graphics. Yeah, you might have somebody on your team that does that. So maybe you want your graphics produced in, AutoCAD or something. You all do have access to those softwares, so if you want AutoCAD on your home PC or laptop, email me if you don't already have that information, and I can give you the free link. It's free. This is better. Don't hear it. And also SolidWorks. So if you want to start playing with it, I really don't want to hear that. Hey, got my graphics in my pocket. I want to 40 hours. You didn't have to do that. You can just draw by hand. Good. Answer your question. AutoCAD and SolidWorks, just because they're in the lab, you wouldn't even have to load them. You could just use them in the lab. Line types, no, it gets complicated. So you might do a assembly drawing. This is an assembly drawing. So those are like, I might make you produce a graphic package for your project. That would be an assembly drawing, which some drawing that shows most or all of the parts in the assembly on one drawing, like this. And then it calls out each part. Part 1, part 2, part 3, part 4, right? So this assembly drawing is essentially a map to the rest of the You don't really, I mean, you can't normally tell how things actually go together in an assembly drawing, but you can identify parts, like, oh, I want to know where the door is, right? And door is number 2, so I can read the schedule over here, and that's drawing 4. Drawing 4, boom, I have to go. And guess what? It's front, top, and side of the door, right? That's where we do the detail stuff. So this is like a map of the project. Again, for the end user, somebody gonna build the thing, then they need this drawing package. Other disciplines other than mechanical use the same thing. Civil engineering, electrical engineering, computer science, I don't know. Mechanical engineering, right? Any of us who produce drawing, we do the same thing. We do this for the graphic design, but it is called something different. Like civil engineering or structural is going to call that a floor plan, right? But what view is it? Top view. Yeah, so let's break down. Maybe it's a section, which means we're going to slice the first floor and we see the floor at the top, right? You could do another slice and have a foundation view. Again, it's the top view, but now we're just looking at the concrete. And then you could do another slice and it could be the second floor plan. And then with the floor high density housing unit, you could have the 48 floor, which probably is like the 47 floor, 46 floor, right? And then front view, like looking at the front of the structure, is called an elevation, but it's a front view. It's just a different name for it. So when you talk to civil engineers, a lot of times they're talking about elevation. Let's look at the elevation. Let's get the elevation drawing out. Let's go out and shoot some elevations, right? Again, that's just a front view of some kind of topical land shape, and then they're going to slice it and then draw an elevation. Again, it's just a front view called something different. All right. The last thing is just some hand graphics, which I'm pretty much out of time. So I'll cover this maybe a little bit on Thursday as we do our ethics. Any questions? So this is where I'm like, okay, I've cranked them up on some engineering graphics. So now when I say produce engineering graphics in the project, I'll get kind of something all the same. See how it's going? I'll cover ethics on Thursday, and then I'm going to make a ethics document, and we'll kind of have a final. So. Right. Good. See you in lab if you have lab today.